In this video, I'll explain continuity of functions of two variables. A function f of x comma y is continuous at a comma b if limit of f of x comma y as x comma y tends to the point a comma b must be equal to the value of the function at a comma b. I have already made a video on how to find limit of function of two variables. If you have not watched that video, link is shared in the description box. Please watch that video first. That will tell you how to find the limit of function of two variables. First, you have to find the limit of function of two variables. If that limit exists, then you have to check the value of the function at the point a comma b. If both limiting value and the function value at a point a comma b are equal, then we say that the given function is continuous at the point a comma b. Now, if this definition is not satisfied, then we call such function as discontinuous function at the given point a comma b. There are different types of discontinuity. In some of the cases, the limit itself doesn't exist, or in some of the cases, limit exists but it might not be equal to the value of the function. So, in case if limit exists and it is not equal to the value of the function at the point a comma b, then such discontinuity is called as removable discontinuity. Now let us solve one problem. Discuss continuity of this function at the origin. So when x comma y is not equal to 0 comma 0, this is the value of the function. If x comma y equal to 0 comma 0, the value of the function is 0. Now first we have to find out the limiting value of the function as x comma y approaches the origin. Then you have to check is it equal to the value of the function at the origin. So it is given here value of the function at origin equal to 0. X comma y equal to 0 comma 0 means value of the function is 0. The one thing we got. Now you have to find out limit of f of x comma y as x comma y tends to 0 comma 0. Now, to approach the origin, there are different paths you can choose, either along the x axis, along y axis, along the line y equal to mx, along the parabola y square equal to x, along the parabola y equal to x square. So, there are different paths, not just one parabola. You can take it as y square equal to mx, and number of parabolas you can get to approach the origin. If the value of the limit remains same along every path, then we say that the limit exists. So that is how to find the limit of a two variable function. Therefore, now I'll choose along y equal to mx. Along the line y equal to mx. This includes x axis, y axis also. When you m equal to 0, then you will get along x axis. So therefore, limit as x tends to 0 to x to the power 4 plus 3 into y power 4 means m power 4 x to the power 4 divided by x square plus m square x square. So this is equal to, let me simplify, limit x tends to 0, x to the power 4 common, 2 plus 3m power 4 divided by x square common, then we will get 1 plus m square. So x square cancels with that of the numerator. 1x square remains in the numerator. So whatever may be this value, 0 into anything, you will get 0. Therefore, along x-axis, along y-axis, or along any line passing through origin, the value of the limit remains same, that is equal to 0. Now, you can check along parabola, that is y square equal to mx or x square equal to my along any parabola. You can check with that, you will get answer equal to 0. Therefore, in every path, the value of the limit equal to 0. Hence, limiting value equal to the function value. Limit of f of x comma y as x comma y tends to 0 comma 0 must is equal to f of 0 comma 0. This is also 0. Function value also 0. Therefore, the given function is continuous at origin at 0 comma 0. Now second problem, discuss the continuity of this function at origin. So we have to first find out the limit of this function as x comma y tends to the origin, and then is limiting value at the origin equal to the function value at the origin. So it is given here f of 0 comma 0 is equal to 0. The value of the function at the origin is 0. Now let us find out the limit of f of x comma y as x comma y tends to 0 comma 0. So we shall find out this limit as x comma y tends to the origin. Therefore, I will choose the path along y equal to mx. So along y equal to mx, along this path, let us find out the limit of this function. So as x tends to 0, because y equal to mx you have to substitute. So you will get here x minus mx whole square divided by x square plus m square x square. So this is equal to limit as x tends to 0, x square plus m square x square plus minus, it is because a minus b whole square formula, minus 2ab 2x into mx divided by x square plus m square x square. We shall simplify this. So we will get limit as x tends to 0. Take x square common, 1 plus x square common, m square minus 2m divided by x square common, 1 plus m square. So x square cancels. When you apply the limit, so limit as x tends to 0, limit as x tends to 0, so it is m minus 1 whole square divided by 1 plus m square. This is that value. So when you apply the limit as x tends to 0, this value changes as you change the value of m. Therefore, along y equal to mx, there is no unique value. When you change the value of m, the limit keeps on changing. Therefore, there does not exist unique value, hence the limit does not exist. If there is no limit, then the function is not continuous. Therefore, f is not continuous at origin. Now, next third problem, check the continuity of this function at origin. So now for this function, I'll use the concept of polar coordinates. That is x equal to r cos theta, y equal to r sin theta. Therefore, first I have to get the limiting value of the function. Then I have to check is limiting value equal to the value of the function at that point. So value of the function at origin is 0. Now let us find out limit of x comma y tends to 0 comma 0. The function is sine of square root of x square plus y square divided by root of x square plus y square. This is equal to when x and y tends to 0, then r also tends to 0 from this expression. So limit r tends to 0, sine of r square cos square theta plus r square sin square theta. So you can take r square common. Cos square theta plus sin square theta is 1. So square root of r square is r divided by the same value here also r. So we know the limit sin theta by theta as theta tends to 0 is always equal to 1. Therefore, this value is equal to 1. The value of the limit as x comma y tends to origin is equal to 1, but the value of the function is 0. Value of the limit not equal to the value of the function at origin. Therefore, f is not continuous at origin. Now, fourth problem, discuss the continuity of this function at origin. So, function value at origin is equal to 0. Next, you have to find out limiting value of this function at origin. Therefore, limit of f of x comma y as x comma y tends to 0 comma 0. You have to choose path. That means to approach the origin, there are different paths, maybe along the line passing through the origin, that is y equal to mx, or through the parabola y square equal to x, or through the parabola x square equal to y, and so on. So first let me check with y equal to mx. So along the path y equal to mx. So substitute y equal to mx. Therefore, limit as extends to 0, x power 4, y is mx, so m power 4, x power 4 divided by x square plus m power 4, x power 4 whole cube. So this is equal to, let me simplify, limit extends to 0, x power 8 into m power 4 divided by, so when you take here x power 2 common, so x square 1 plus m power 4 into x square whole cube. So that is equal to, limit extends to 0, x power 8 into m power 4 divided by x square whole cube, that is x power 6 into 1 plus x square m power 4 whole cube. Now 1 x power 6 here cancels with that of the numerator, 1 x square remains. Whatever may be the value of m, as there is x square in the numerator, when you apply the limit, x tends to 0, 0 into any value, you will get it as 0. So therefore, for any line passing through the origin, if you have chosen that path, then the value of the limit is 0. But still we can't conclude the limit exists and its value is 0, because now I will choose another path, y square equal to x. So along y square equal to x, let us check what is the limit of this function. Limit of f of x comma y as x comma y tends to 0, this is equal to limit as x tends to 0, because y square equal to x, when x tends to 0, this value also tend to 0. So x power 4 into y square is x, y power 4 is x square divided by x square plus x square whole cube. So this is equal to, limit as x tends to 0, this is x power 6 divided by 2x square whole cube. So 2 cube is 8. X square whole cube is x to the power 6. X power 6 cancels. The value will be 1 by 8. If limit exists, then it should be unique. That is not obtained here. Therefore, limit does not exist. Hence, the function is not continuous at the origin. Now here there is a problem. You have to check the continuity of this function at origin. So as you know, which we have applied before, we have to usually check with the different paths, starting with y equal to mx, and then y equal to x square, then y square equal to x. These are the possible paths we have taken so far. Or else we have to change it to the polar coordinates. If the value of the limit is dependent on theta, limit does not exist. Those were the case we have seen so far. But changing to polar coordinates or changing to y equal to mx, sometimes they don't give you the true result. So this is an example. If they are giving you a particular value, that doesn't mean the limit exists. You have to go with all possible paths. There could be some other path where the limit does not exist. So here the value of the function at origin is equal to 0. Therefore, we have to get the limit of f of x. So I will first take along y equal to mx. So limit as x tends to 0, I'll apply directly x square, y square is m square x square divided by x cube plus m cube into x cube. So this is equal to, limit as x tends to 0, x to the power 4 into m square divided by x cube common 1 plus m cube. So x cube cancels with that of the numerator, 1x remains in the numerator. So when you apply the limit as x tends to 0, 0 into any value, it becomes 0. So here we got the value of the limit as 0. Now I will choose one more path along y equal to x square. So along this path, limit as x tends to 0, x square, y square is x to the power 4 divided by x cube plus y cube is x to the power 6. So this is equal to, limit as x tends to 0, x to the power 6 divided by, here when you take x cube common, 1 plus x cube, x cube cancels with that of numerator. Therefore, 1 x cube remains in the numerator. 0 as extends to 0, 0 by any value you will get 0. 0 by 1 it is equal to 0. So along this path also you got the value of the limit as 0. Now I'll choose another curve along y equal to minus x into e to the power x. As this curve passes through the origin, you can approach the origin through this path as well. So when I apply it in the given function, x tends to 0, x square into y square is minus x e to the power x whole square divided by x cube plus y cube is minus x e to the power x whole cube. So let us simplify this. This is equal to limit as x tends to 0. So minus of minus plus, because there is a square, x square into x square, it is x to the power 4 into e to the power 2x divided by x cube minus x cube into e to the power 3x. So when I take x cube outside, so then I'll get limit as x tends to 0. So I'll get here x to the power 4 into e to the power 2x divided by x cube common 1 minus e to the power 3x. Now x cube cancels with that of numerator, 1x remains in the numerator. So we will have limit as x tends to 0, x into e to the power 2x divided by 1 minus e to the power 3x. So here if you apply the limit, then I will get 0 by 0 form. That is because 0 into any value 0, e to the power 0 is 1, 1 minus 1, 0. So 0 by 0 form. So for that I will apply L'Hospital's rule. So you will get limit as x tends to 0. Differentiate the numerator and the denominator separately. So product rule to the numerator, 2 into e to the power 2x plus e to the power 2x into 1 divided by derivative of 1 is 0 minus 3 into e to the power 3x. Now apply the limit. So this is equal to, as x tends to 0, this value is 0. This is 1 divided by, this is also 1, minus 1 by 3. The value of this limit is minus 1 by 3. Whereas along y equal to mx, we got the value of the limit as 0. Along the curve y equal to x square also, we got the value of the limit equal to 0. Now I have chosen a different path, y equal to minus x e to the power x. We got the value of the limit as minus 1 by 3. That is not unique. Therefore, limit does not exist. Hence, the function is not continuous at origin. This is how we check the continuity of given function. To check the continuity, we have to check is limiting value of the function equal to the value of the function at that point. If that happens, then the function is continuous at the given point. Otherwise, it is not continuous. So to check the continuity, we need to find out the limit. So usually limit is found along y equal to mx, this path, then y equal to x square, then using polar coordinates also. If it is dependent on theta, then the limit does not exist, but sometimes these also will give you the false result. This is an example. In that case, you have to go with some other paths to make sure that whether the limit exists or not. I hope you understood the concept. Thank you for watching.